So here's some context. 2 weeks ago, I'm sitting in philosophy class, and we start talking about hemoglobin. I'm like, wait, that's cool. Cats have blood. I have a channel about cats. Beam, bam, boom. Great idea. I text my FBI agent so that they're prepared for what I'm about to research, then proceed to spend my whole weekend researching cat blood. I need other hobbies. I hop onto Google and start searching for info on cat hemoglobin. The only thing that comes up is cat anemia, but that's kinda not what I'm looking for, so it's useless. Next, I resorted to Google Scholar. No, wait, it was EBSCO. What? It's free for university students. Anyway, I found like 2 papers, and either I'm doing this wrong, or I'm doing this wrong, or it's not a hot topic in the cat research world. Whatever, well, let's just work with what we got, you know? Okay, here's what I found. Let me break it down for you. If you're a Gen Alpha baby, then it's your cue to skip ahead. I'll even leave a timer for you, you know? Just chill. Yeah. Now that the kids are gone, let's get into the statistics. Hemoglobin makes your blood red, but its main job is to carry oxygen around your body. It absorbs oxygen from your lungs and releases it in the tissue. Scientists love using oxygen dissociation curves to show how much oxygen hemoglobin is carrying. It's simple, really. Line goes up, hemoglobin grabs oxygen, line goes down, hemoglobin lets go of oxygen. Cool, now that you understand that. Different parts of the body make the graph look different. Like, there's lots of oxygen in the lungs, so hemoglobin likes to grab it more, while less oxygen in the tissue means hemoglobin releases it more. And then, if you look right here, here's the cool part. Wait for it. Boom! The Bohr shift.
More like boring shift.
To sum it up, this graph can shift left or right depending on conditions like pH, temperature, and oxygen levels. Animals at high altitudes, for example, usually have hemoglobin that's super greedy with oxygen, which helps them survive, but makes them less active as a trade-off. Okay, now back to cats, which is probably the only reason you're here. Cats have 3 types of hemoglobin A, each acting like siblings with very different personalities. Type 2 is the responsible oldest child. It does most of the work, grabs oxygen efficiently, and lets it go when it's needed. Type 3 is the middle child. It's there, it does stuff, but it kind of just like exists. It's not as good as type 2. It's kind of average at everything. And type 1, you ask, it's the youngest, most self-absorbed, greedy piece of shit. It's greedy. It takes in oxygen a little too well. Sharing, not its thing. This immediately made me think of cats' behavior. Short bursts of intense play rather than hours of non-stop activity like dogs. It could be linked to their oxygen-greedy hemoglobin, which makes sense because their ancestors were used to living in high-altitude environments.
Oh, hey. Yeah? Mm-hmm.
So let's not get ahead of ourselves. Ambush behavior isn't necessarily due to their blood. Plenty of animals have blood that helps their stamina do this. Ambush hunting is energy efficient and gives a higher chance of success if prey doesn't see you coming. Sounds like a great strategy.
Ladies and gentlemen, we got him.
So maybe hemoglobin doesn't cause zoomies after all, but it could explain why cats rest for so long afterwards. Cats cannot catch their breaths as fast as us, so their bodies need time to reset before they're back to 100%. So what does this mean for you, the average cat owner? It means that when you play with your cat, take breaks. Try not to go over 20 minutes of intense play. Of course, it depends on the cat. Some are done after 5 minutes, and while others can go for hours. But either way, playtime is important. A happy cat is one that you spend time with, not just one that roams around entertaining itself.